Hello guys, welcome to my channel Engineering to You, and in this video we're going to learn how to find the resultant force of a system of concurrent forces as shown in this example, and this is taken from Hibbeler's Engineering Mechanics 14th edition. So let's review some things before solving the problem. So we have this parallelogram figure, this quadrilateral. We know that the opposing angles are the same, so meaning that these two angles have to be the same, and these two angles, the opposing angles, the opposite angles, the ones that are facing one another, they have to measure the same angle. So like this is alpha, this has to be alpha, and if this is beta, this has to be beta too. So another important thing to remember is that the sum of all the interior angles of the parallelogram or any quadrilateral, in fact, have to be 360 degrees. Okay, so that's the parallelogram. Now the triangle, it's important to remember how to name the triangle or to label any general triangle. Let's say that we're giving any specific triangle and they want us to name it. Let's say sometimes they give you they tell you triangle ABC, and so how do you identify those kind of things, like what is A, what is B? So the way how I do it is I name the angles. I think the author Hibbeler does it differently, but I think this makes more sense. At least I think it makes more sense for because of the angles. So the angles, I'm just going to label them with uppercase letters A, B, and C in no particular order. I just chose A, B, and C just because of the ordering of the alphabet. So A, B, and C, and the sides that are facing that respective angle. So like in this case, the side that is facing this angle is going to be the respective lowercase letter. So in this case, the side that is facing the angle B is going to be lowercase letter b, and the side that is facing angle C is going to be angle side C. So this way we don't get confused. So let's say that we're giving this any random triangle. So I'm just going to choose A, B, and C for the angles, and the sides that are opposing that respective angle, I'm just going to name them with the respective lowercase letter. So C and B, right? Okay, so that is important. Something else before actually solving the problem is related to the law of sines and cosines from, do you remember from trigonometry? We're going to refresh them real quick just to make sure that we know it. This is called the law of cosines, and following the pattern, following the name of this triangle ABC, of a triangle ABC, we know that the law of cosines says that c squared has to be the same as a squared plus b squared minus 2 times ab times the cosine of c. That is what the law of cosine says. And there's different ways. There's other alternatives of describing this law of cosines. Let's say that another way of doing it is a squared is equal to b squared plus c squared minus 2bc times the cosine of a. And just for completeness, I'm just going to give you the other one. It's b squared. There's only three. B squared is equal to a squared plus c squared minus 2ac times the cosine of b. And sorry, and this is following this triangle. And once you label the triangle, make sure you do not change it. So like in this case, the sides, angles, and well, basically just the sides and angles have to be the same throughout. So in order for this to be true, these have to be in this respective order. Now regarding the law of cosines, just an intuitive way of doing it, of visualizing it, of how it works, it is just basically like the Pythagorean theorem. So like c squared, like one side squared is going to be equal to the sum of the squares of the remaining two sides. So you have c squared, you choose c squared, and the remaining two sides are what? Are a and b. So you're going to be c squared, it's just like the Pythagorean theorem, c squared equals to a squared plus b squared, minus, we're going to add a little bit, minus 2, that is part of the formula, times the lengths, the two respective remaining lengths, a times b, times the cosine of this respective angle. So it's easy to visualize it in that way. So that way you don't have to memorize any formulas or anything. So let's try for this one. So like b squared, you choose b squared. What are the remaining two sides? There are a and c. They're the remaining two sides. So we're gonna, it's just like the first is the Pythagorean theorem. You can't get that wrong. B squared is equal to a squared plus c squared. And you're gonna add a little bit, minus 2, this part of the formula, times a times c, times the product of the remaining two sides, times the cosine of b, of the angle that is formed between the remaining two sides, or the angle of this side that you're trying to find. Okay, so so that is the law of cosines, basically. Now there's also this thing that we have that is called the law of sines, and this one is basically, and again following triangle A, B, and C. This one says basically there's different ways of writing it, but I think this is the most general way. Sine of A over A, or A over sine of A, has to be equal to B over sine of B, and has to be equal to C over sine of C. So what does that mean? That A, or like side A divided by the sine of this angle, angle A, has to be equal to the side B divided by the angle B, and side C over the sine of the sine of C, this angle, and all that has to be the same. So like that ratio has to be constant in any triangle. So usually how we do it in mechanics, or in engineering mechanics, is we use the law of cosine first, usually, and we do it most often when we're trying to find sides, and then we go to step number 2. Number 2, we use the law of cosines usually to get angles. Now, why do we do it like this? We do it like this because the law of cosines is very useful for obtaining sides that we do not know. We were usually given 2 unknown sides and 1 known angle. So so like 2 unknown sides, so A and B, and 1 unknown angle, C, and we just need to find, let's say, C. Okay, so it's two unknowns, 3 knowns and 1 unknown in the equation. And then we use the law of sines to find angles, because it provides a very fast, quick means to obtaining them. I mean, just look at this. It's just a quotient. I mean, there's no squares, there's no cosines or anything, or minus 2 times no. Everything is just straightforward. So like, if we wanted to find angle A and we don't have it, as we're gonna see in this example, this law of sines is very useful, because we're gonna find this constant. Let's say that we know the value of C and the sine of the angle, so we have this constant, and maybe we're given this A and we're trying to find this angle, sine of A. We could use the law of cosines, but it, like I said, is very useful. It's very straightforward if we use the law of sines. And in mechanics, you want things that are exact but also easy to use. So I think that is pretty much. Oh, and also, yeah, just quick thing. Just as we have the sum of the interior angles of the parallelogram are 360, the sum of the interior angles of the triangle are 180. And like I said, these are things that you already know. Well, like we should know already. But just to refresh your memory and to help you in this example. So let's actually solve this problem. So it says determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. So the way how we do it is we're going to apply what is called the parallelogram. I think it's only one R. Yeah. I don't even know. The parallelogram law. Okay. The parallelogram law. This thing that we have that is called the parallelogram law. Okay, so we're gonna start. You see how this is a vector. It goes from this vector right here is 800 newtons right here, and this vector right here is acting at an angle is 600 newtons. Okay, so the right here, the parallelogram law says that we're gonna start at the tip of each vector. So we're gonna start right here. We're gonna start at the tip of this 800 Newton vector, and we're gonna draw lines that are parallel to the other vector. So I'm gonna try to draw a line that is parallel to the other vector. So this line it's intended to be parallel to this vector. Okay, so I just do it, and I'm gonna go to the other vector, and I'm gonna do the same thing. I'm gonna draw a line that is parallel to the other vector. In this case, to the one that is acting along the y-axis. Okay, so real quick. Okay, and you see this point right here. I'm just gonna call that point R. Okay, the parallelogram law says that the diagonal, you see how we have now a quadrilateral? The parallelogram law says that the diagonal that forms between from the newly made parallelogram, this diagonal represents the resultant force of the two vectors. So meaning that you have this quadrilateral, and the diagonal that goes from one point to another is actually, and geometrically, in terms of lengths and proportions, it is the resultant force. So this is basically what the parallelogram law says. Now after this one, we're going to apply something called the triangle rule, which is basically the same thing as a parallelogram law, but it's like a subdivision. It's like a subset of the parallelogram law. Now what we're going to do is the triangle rule is also known as AKA head to tail. Do you remember that from maybe physics or something? You get the head of a vector and you place it in the tail of the other vector, and the resultant force represents that vector that goes from one point to another. And you'll see it real quick. Look, I'm gonna draw this. So you consider this 600 Newton vector at the bottom, and I'm gonna take this vector right here, and I'm gonna place it on this line of action, this vertical line. Okay, I'm just gonna delete all that. Okay, I'm gonna place it right here, and this, we have an 800 Newton vector. It's the same thing. So now we know that basically what I'm doing is I'm placing the tail, or the tail of the vector, on the head of the first vector, and you see how it's actually it fulfills the requirement. The vector, the resultant force, goes from the origin to the final point R. Okay. Now in terms of the mechanics, that's it. So like the actual engineering mechanics, it actually stops there. Everything else from now is just geometry and math. Okay, so let's find the magnitude of FR. Okay, now I want you to look at this side, to focus your attention on this triangle. Okay, triangle right here, and we're going to remember that in vector, in calculations with vectors, the length of the length of the ray of the vector represents the magnitude. So it does not mean that from here to here is 600 newtons or like 600 feet or anything. It's a unit. It's just to represent the magnitude. Okay, not any specific actual physical quantity other than the ones that is explained by the vector. It's not actually drawn to scale. In fact, this is a unit of force, not of distance. So, but we can treat it as distances just for our convenience. So basically, we have right here a triangle. We can treat this as a triangle from here to here, and from here to here, something kind of like that. Okay, so from here to here, and you know that this point right here is 800 units, and this point right here is 800 units, and you're trying to find this FR. Now this is very similar to our review example that we had. So, but we need one more piece of information. Remember, because we need to have 3 pieces of information, we need one more. So how can we do it? So the way how we're going to do it is look at this 30-degree angle. So can we find this angle that ranges from here to here of the parallelogram? Because if we do, we can find the opposing angle, and then be able to, with that equality and the fact that the sum of all the interior angles are 360, be able to find this angle right here, which is the same as this angle. But we don't need this angle. We need specifically, we need to obtain this angle, because when this angle is actually this angle, and once we have this angle, we can proceed with using the law of cosines. Okay, so how can we do it? Well, look at this right here. This vector is acting along the y-axis, and this angle of inclination of depression is 330 degrees below the x-axis. So it forms a 90-degree angle. So we only need to add 90 degrees, right? Because this is 90 degrees to 30, and we're able to find this angle. So 90 plus 30, that's 120. Okay. So, and 120 has to be the same as this. Remember, because opposing side or opposite sides, opposite angles, I'm sorry, are the same. So once that we have that, we can employ the fact that the interior angles are 360. So 2 times 120 plus 2 times this unknown angle, I'm just going to call it x, equals to 360. They has to be equals to 360. If you divide everything by 2, you have that 120 plus x equals 180. 180. So x is equal to 60 degrees. Okay, so there we have it. So read right here, we have a 60-degree angle. So let's name this triangle. This is why I wanted to highlight the importance of naming the triangle, because we're going to use the law of cosines and sines. So let's name this triangle in no particular order. So I'm just going to name it A, B, C. And if that is ABC, that means that opposing sides that are opposing the angle are, let's say that this one is B, little b, and this one right here is little a, and this one right here is little c. And we're trying to find little c. Okay, so right now we're gonna apply the law of cosines. Now, because we want to find c, I'm gonna use the version of the law of cosines that uses c. But remember, we're not gonna memorize formulas here. We're gonna learn together. So c squared is equal to, just like the Pythagorean theorem, a squared plus b squared minus, so you choose one side and the remaining two sides are a and b, minus 2 times the product of the remaining two sides times the cosine of the angle that is formed between the remaining two sides, or the angle that corresponds to this c, which is It's not B, sorry, it's C. Okay, so that means that C is equal to the square root of A squared plus B squared minus 2AB times the cosine of C. And remember, the cosine has to be in degrees. So C is equal to A. What is A? A is 800 units. And B is going to be 600 units squared. Don't forget the square. Minus 2 times 800 times 600 times the cosine of what angle? Of what is the of angle C, of this angle right here. Okay? So times the cosine of 60 degrees. And you take the whole square root of that. And we can compute this value. And this value comes up to be 721.11. Now, this is a unit of distance, but since we represent the magnitude of vectors as lengths, we can surely say with no mistake that the resultant force is equal to 721.11 units of newtons. Do not forget the units. Do not forget the units. Okay, so right here. Now they're also asking for the direction of the force, the direction of they're asking for the direction. So we need to find this angle from the positive x-axis to this resultant vector, which we already know the value to. And the way to go about it is to let's use some geometry to figure out the easiest way to do it. Now, look at this side right here. Right here. Look at this side, this angle right here. The angle that goes from here to here is actually this one. So angle A. Angle A right here. And if angle A is actually composed of this angle of interest that we want to find plus a 30 degrees. So an angle of interest that we want to find, this is one to want to find, plus 30 degrees gives us the angle A. And how can we obtain angle A? Well, remember, we usually go from step number one, law of cosines, and then we proceed to law of sines to find angles. Law of cosines usually is used for finding sides, and the law of sines is for angles. So we're going to use the law of sines. Why? Because it is more convenient. We could use the law of cosines, but it's not as convenient. It's faster to use the law of sines, and you'll see why right now. So you're gonna say that the law of sines, remember the law of sines is the sine of A over A equals to the sine of C over C. Now this one is also equal to, just for completeness, sine of B over B. But we do not know angle B. We do not know this angle, and honestly we don't need it. So I'm going to disregard this one because we do not need it. So let's look at our knowns and unknowns. Do we know angle C? Yes, it's 60 degrees. Do we know side C? Yes, it's FR. We just calculated it. We know it. Do we know side A? Yes, we know it. It's right here. It's 800 units, 800 newtons. And do we know angle A? This is what we're trying to find. So it's just basically one equation, one unknown. And this is the reason why we use the law of cosines. It's faster. If we would have used the law of sines, and if we would have used the law of cosines, it would have been like we would have had to isolate the cosine and then inverse cosine, and then account for the square root, positive, negative, and we want things that are faster, quicker, and efficient. And that's really important in engineering, efficient. So let's solve for A. So sine of A is equal to A over C times the sine of C algebraically. So the measure of angle A is equal to the inverse sine of A over C times the sine of C. And now everything, it just becomes a matter of plug and chug. So the measure of angle A is equal to the sine, the inverse sine of A. What is A? Is 800, and the newtons are going to cancel because you're going to have newtons over newton, and those things are going to cancel. So do not worry about the units as of now. And then C is the one that we just obtained, is 721.11 times the sine of what? Of C, and C was 60 degrees. Remember, C is this angle right here. So 60 degrees, 60 degrees. So if you perform this calculation, the measure of angle A is more or less approximately 73.898 degrees. Okay? Now, this angle A, remember, is the angle that ranges from these two sides, from look at the pink arrow, because I don't want to draw anymore. From here to here, this is 73 degrees. But remember, we're not trying to find for those 73 degrees. We're trying to find for this angle theta that starts from the positive x-axis to the magnitude to the side of the resultant vector. So all we have to do is solve for theta. Theta is equal to the angle A minus 30 degrees. And all we had to do is theta is equal to A is equal to 73.898 minus 30 degrees. Theta is approximately equal to, it's 43.1 degrees. And we just found our answers. So this answer right here is the answer to the resultant force, and it's acting at this specific angle. Now, just to conclude this problem, I'm gonna go ahead and try to do something real quick just to show you more or less what is happening in the physical. So yes, we just did the math, but what is actually happening in the physical world? So actually what is happening is that we're adding these two forces, this vector that is going upwards and this another vector that is going downwards from at an angle of 30 degrees from the positive x-axis, and we came up that it had to be around this angle according to the parallelogram law, more or less. And this force came up to be Fr like around 721 newtons, and it's acting at an angle of 43.1 from the positive x-axis. So what that means is that you could replace this vector, like totally erase it or ignore it, and change those two vectors by a force of 721 newtons that is acting at 43.1 degrees from the positive x-axis. And it does not matter the type of, as of this course, as of the statics course, the type of effect of the force. It could be a different body, a different hook, or a different material of the rope, or anything. It does not matter. As long as it has the same direction, line of action, like this line of action and this one, and at those specific magnitudes and angles, it does not matter. We can replace them by this specific force and at this specific angle, and it's going to have the exact same effect. And that is the actual definition of a resultant force, changing everything you have by one simplified system that is easier to analyze and more efficient, and with in less time and with less errors. So if you found this helpful, give it a like, subscribe, and let me know what you think. I'm gonna be uploading more videos of statics, and I'm gonna do it I'm gonna try to do it every day, and so that I can help you guys. This channel is intended to help you and to aspire to prepare you not only in academia but also in the professional field. So I hope you found this helpful, as I enjoyed doing it. So thank you, and subscribe and like if you liked it, and let me know what you want to see next. And thank you guys.